A very good evening to all the participants in the webinar, which is organized by UPES Dehradun. Myself, Venkatesh Chintala, Assistant Professor in the Department of Mechanical Engineering, College of Engineering Studies, UPES Dehradun. I will provide an insight on domain-specific program BTech, Mechanical Engineering with specialization in Thermal Engineering. The agenda for the webinar is as follows: mechanical engineering, importance of the mechanical engineering, why the thermal engineering expertise is required, about the new program, that is BTech mechanical engineering with specialization in thermal engineering, and program structure, the laboratory facilities available here at UPES, and finally the significant career opportunities with the specialization in thermal engineering. Let me give brief details about the importance of mechanical engineering. Mechanical engineering as a diversified field that derives its breadth from the need to design and manufacture everything from small to large systems or parts or equipment. A small system may include sensors, transistors that are used in electronic industry. A large system may be including gas turbine blades or cooling towers. So from small system to large system, any design is including mechanical engineering expertise. Over the years, mechanical engineering has grown tremendously and has become integral part in shaping our world today. Significant role of mechanical engineering is for coming up any product from an idea to marketplace. A mechanical engineer role is existing. As I have mentioned here, from mind to market, whatever the product which has to be made, that comes through an idea which is in our mind. From mind to the realization of the product in market. So between this flow path, a mechanical engineer exists. In each and every aspect of this path, mechanical engineer plays a vital role for physical realization of the any product. A qualified mechanical engineer can be say as a jack of all trades. He is the basis, or he is the a benchmark for all types of trades of different fields, from starting from electronics to automotive, aerospace and all. We can say a mechanical engineer is forefront of future technologies. Whatever the future technologies that we are doing R&D, those for all those future technologies or future systems, mechanical engineers would be our forefront leaders. Mechanical engineers play a key role in various industries. For example, automotive industries, which consists of passenger transportation and mass transportation, aerospace and air applications, which also includes air transportation, biotechnology field, in which fluid systems for pharmaceutical industries, and in computers and electronics industries, where we see the major applications of drives, printers, cooling systems, semiconductor tools and so on. In these all fields, mechanical engineers plays a key and vital role. And some other industries like micro electromechanical systems, where we do observe sensors, micro power generation systems and so on. Energy conversion systems like gas turbines, wind turbines, solar energy, and in the field of fuel cells, which convert energy from chemical to the electricity. And environmental control systems, heating, ventilation, air conditioning systems, air conditioning and refrigeration, and different types of compressors. In the field of automation, where robots, data and image acquisition and recognition of human and biometrics and control systems. At the last, manufacturing sectors. So in all these sectors and fields, mechanical engineers play a key role. Now we'll see the thermal engineering specialization or thermal engineering expertise, why it is required. What about the conventional mechanical engineering, and what are the significant differences with BTech in mechanical engineering or BTech mechanical engineering with specialization in thermal. Energy, energy related topics such as sustainability, renewable energy, clean and green energy. These are the terms which we frequently use, and these are considered frequently cited as the most cutting edge disciplines for the coming next 10 to 20 years. In all these energy sectors, energy fields, significant technological developments or significant modification systems in terms of energy efficiency are required. This energy efficiency, again, it reminds us the thermal assessment or thermal analysis of the systems. These technologies, such some examples as mentioned below, as low temperature resources, where we'll use many types of Rankine cycles or different types of systems, thermodynamic cycles we'll use for getting power conversion or for getting energy conversion. Similarly, other applications like waste heat analysis, process heating assessment, combined heat and power applications. In all these fields, the thermal assessment or thermal analysis play a significant role where with conventional mechanical engineering it may not be the feasible. So if you have expertise in thermal engineering subjects or like advanced thermodynamics, advanced thermal engineering and advanced heat transfer analysis, mass transfer analysis, if we have expertise on these fields, then we can handle these all type of technologies and systems with expert opinions. As it is mentioned, increasingly desirable skills on thermal equipments are needed. Thermal equipments, it reminds us as heat exchangers, boilers, cooling towers, and so on. Professionals in the field of thermal engineering strive to develop a more efficient means for transferring energy from one form to another means. Another expertise in heat transfer is helpful in conversion of energy from any form, chemical or fuel, whatever may be, to electricity or the required form. This expertise will be very helpful. Transforming power grids to create more affordable electricity has become one of the most popular fields utilizing expertise of thermal engineers. Thermal engineers dedicate their efforts to refining electronic systems and safety applications. Heat transfer in processes and equipments like electronic devices, there also expertise or uh, expertise in the thermal engineering would be helpful. Heating and cooling systems, where sustainability of the systems is necessary. So thermal engineering or heat transfer expertise is significantly required. Human comfort preservation, which remains the area or the field of refrigeration and air conditioning, which involves temperature and which involves humidity, all which concerns the thermal analysis or thermal assessment. As I have shown some figures which depicts as laptop or computer systems in the field of computer era, cooling of integrated circuits, printed circuit boards, PCBs, microchannels. In all these applications, cooling and heat transfer rate, higher heat transfer rates are significantly required. Suppose if I take a laptop, if it having a problem with the cooling fan, so immediately it gets down because of cooling problem. So there, cooling of microchannels and cooling of the ICs is majorly required urgent emergency need. Otherwise, my system will get down. Similarly, in automotive applications, where engine design comes up for analyzing the performance and emissions, we need thermal analysis. If I talk about the performance of the engine, definitely I would say the combustion. I would remind the combustion inside the combustion chamber of the engine. Combustion again is a function of temperature. at higher temperatures will get higher performance. So majorly I would like to say, without thermal analysis, analyzing engine or automotive applications would be meaningless. I have to be depend on thermal analysis where my thermal engineering expertise is significantly required. The other application is aviation. As we have seen in the figure, gas turbines are located at both sides of the wings on the aeroplane aircraft, in which gas turbine blades were exposed to high temperatures. Gas turbine consists of uh, turbine blades which made up of alloy steels for withstanding high temperatures. I mean to say here the turbine blades are overall turbine gas turbine uh, path fluid path is exposed to high temperatures where the combustion is taking place, combustion chamber and turbine. These are all the parts where high temperature is exposed. If we want to analyze the effectively the failure of the blades, similarly failure of the gas turbine engine, similarly failure of the my whole system which is a gas turbine, I need expertise in thermal in the field of thermal engineering. The another field, as I was mentioning, energy, solar energy, renewable energy, green energy. In all these equipments, energy efficiency is the major thrust where researchers, industrialists, scientists, and many people are striving through for improving the energy efficiency of the system. Without energy we cannot expect, we cannot assume the universe is driven by the energy. So everywhere we assume and we presume and we strive to achieve for improvement of the energy efficiency of the given system. So for improving energy efficiency, again I have to depend, I have to rely on thermal assessment, thermal analysis of the system. The another field important, which is global warming and environment, where emissions will come up into our mind, like greenhouse gas emissions like CO2, carbon dioxide, nitrous oxide, methane, and so on. These emissions again are dependent on the temperatures and thermal performance of the systems. The another field of thermal analysis expertise is required is healthcare, where design and thermal equipment of instruments is deadly needed. Here some more figures I am showing in this slide as a heat exchanger, where thermal analysis, big heat exchangers that are used in industries where thermal engineering expertise is deadly needed. This is a figure showing cooling tower and cooling towers used in industries. Here also the different knowledge on heat transfer subjects, thermal engineering subjects is required for heat transfer and the fluid flow where the gas is flowing from bottom to the up part of the cooling towers, and these fluid characteristics along with the thermal stresses and thermal analysis expertise of thermal engineering is required. Here the figure depicts gas turbine blades, as I was mentioning rightly in in the earlier slides. Gas turbine blades again exposed to high temperatures, where to handle these high temperatures we should have the knowledge, expert knowledge on thermal engineering side. One more application, combined heat and power process. Here the flow diagram in CHP application is mentioned. For analyzing combined heat and power application system, again thermal analysis, thermal engineering expertise is required. The typical waste heat recovery system is shown in the figure. So these are the various fields and sectors where my conventional engineering knowledge may not be suitable for assessing the systems. Here I need expertise knowledge in the specific field. The figure depicts solar energy systems, solar power plant, and the circuit boards which are used in electronic devices, where the CFD analysis is depicted, is shown. Cooling of the objects, cooling of the transistors, cooling of the electronic components, and airflow is shown in this figure. And cooling of the turbine blades, CFD analysis, computational fluid dynamics analysis are, for example, I have mentioned here some of the applications where we need the expertise of fluid dynamics along with the thermal analysis. Finally, I would like to emphasize that mechanical engineers acquired with additional expertise in thermal engineering are highly valued in corporate work. Now we will see about the new program, BTech Mechanical Engineering with specialization in thermal engineering. The new program is consisting majorly three categories: core courses, which covers from first semester to six semesters. In aligned with the mechanical engineering program, all subjects are common with the mechanical engineering program. In sixth and eighth semesters, where program electives come up based on thermal engineering expertise. From here, sixth sem onwards, we take the students towards the thermal expertise, thermal engineering expertise. Majorly, all electives are focused on thermal engineering subjects such as advanced thermodynamics, advanced heat transfer analysis, waste heat recovery systems, thermal analysis of waste heat recovery systems, and thermal assessment of low temperature heat sources like solar energy and waste heat, process heat, and finally a major project which is specialized in thermal engineering may come up, may align with the fluid flow analysis. Here the slide depicts the differences between conventional mechanical engineering with expertise in thermal engineering. The course, the proposed program, BTech Mechanical Engineering with expertise in thermal engineering, imparts basic science and engineering subjects in first year, first and second semesters, and fundamentals of mechanical engineering subjects like engineering mechanics, workshop technology, engineering graphics, thermal analysis of systems, equipment, processes, and energy efficiency and exergy efficiency of the systems, expertise on low temperature resources, waste heat and process heating systems, and expertise on heat exchangers, evaporators, cooling towers, computational fluid dynamic analysis in concern with thermal stresses, solar thermal technologies, renewable and alternative energy sources, impact of thermal equipment on environment, especially focused with respect to greenhouse gas emissions. If you observe this slide, the major focus is on thermal engineering side. From third point onwards, all subjects are moving around with around the thermal engineering, thermal analysis and thermal assessment of heat exchangers, power evaporators, cooling towers, and refrigeration and air conditioning systems. These in these all fields, thermal expertise is deadly needed. Based on this thermal expertise, the new program is proposed. Coming to the program structure, in semester 1, as basic sciences will be taught, mathematics, physics, design thinking, environmental studies, engineering mechanics, workshop technology, computer programming, and so on, along with the practicals in physics and workshop and computer programming laboratories. Here the course design thinking is online course where a student can explore himself on various aspects of the practical life for realization of any idea to the market into the real field. The process under which we can go through that we can assess in these subjects, we can observe in these subjects, and we can learn many thinking abilities. We can go through thinking abilities in these subjects. In second semester, again the basic sciences, mathematics to physics and communication, graphics, basic electrical and electronics, chemistry. These subjects students will be go through. Other engineering branches, core engineering branches like electricals, basic electronics, civil engineering, all subjects will be covered in first and second years along with the core mechanical, because uh, true mechanical engineer should have the knowledge with other engineering fields as well. Again in third semester, the mechanical engineering, basic mechanical engineering subjects like fluid mechanics and machines, material science, machine and assembly drawing, engineering thermodynamics, advanced thermodynamics. These subjects will go through along with the practicals. Theory of machines and vibration analysis, mechanical measurement and metrology, mechanics of materials, manufacturing technology, thermal engineering, open electives. From semester 4 onwards, we will see the subjects majorly focused on thermal engineering. And fifth semester again, we'll see the manufacturing technology, turbo machinery, design of machine elements, applied numerical techniques, through which a student can go through many numerical analysis. From semester 6 onwards, the subjects like IC engines, internal combustion engines, heat transfer, operation research, program electives, these subjects will go through. Semester 8 subjects are as follows: CAD, CAM, computer aided design and computer aided manufacturing, and the electives based on thermal engineering expertise. Here, at the end of third year, students will also go through industrial visit and industrial training as the requirement, as per the requirement, and as per the field. They will go through specific industries like power plants, where the thermal engineering subjects are dealt with. In 8th semester, automatic control and the project will go through. As I was mentioning in earlier slides, the program electives for this specialization in thermal engineering program are purely based on thermal engineering side, thermal engineering field, as the subjects like refrigeration and air conditioning, steam and gas turbines, low temperature resources, heat exchangers, experimental methods in thermal engineering, solar thermal technology. So these are the different thermal engineering subjects, and also like advanced thermodynamics, energy management, power plant engineering, where the cooling towers, thermal analysis of cooling towers will students will study in these subjects, along with the computational fluid dynamics CFD in aligned with the thermal analysis, and convective heat transfer, where the major application uh, is convective heat transfer mode. As we are all aware, the under three types of heat transfer modes: conduction, convection and radiation. So many of the heat transfer modes involves convective heat transfer. So these subjects, in these subjects we can uh, specially deal with the heat transfer based on the convection, and gas dynamics, air conditioning system and design, steam generators, waste heat recovery systems. As the slide depicts, the concerns on thermodynamics or thermal engineering or advanced thermodynamics, which is the major requirement from the corporate world from the industry point of view. As the program also consisting of some open electives, students has to select some open electives from other departments like professional ethics, other departments. We can select the subjects like professional ethics, employment communication, industrial management, sociology, philosophy, report writing, and so on. We do have laboratory facility at UPES for learning and practicing and working R&D in the field of thermal engineering. As in first and second years, the students will go through basic sciences and basic mechanical engineering subjects. The laboratory facility in workshop, foundry, fitting, welding will be helpful for enhancing his knowledge in basic mechanical engineering subjects. The figure depicts blacksmith section where forging can be done, machine shop and measurement laboratory where students will go through all basic fundamental machining processes like on lathe machines, drilling machines, and grinding machines, and milling machine. So different machinery setups are available in the UPES. So students can avail this facility and can work for their knowledge enhancements in the field of mechanical engineering. Along with this, as the era is based on the CAD and CAM, so we do have CAM facility. The laboratory facility of internal combustion engines and computer controlling machines. In internal combustion engine subjects, as I was mentioning earlier, students can go through performance and emission analysis of internal combustion engines, which is a major helpful in automotive industry for designing of any engine, along with combustion analysis also. So the facility providing for engine analysis is helpful for enhancing their knowledge in the field of mechanical engineering with thermal expertise. Here the facility of material testing laboratory and fluid mechanics and machinery laboratories are shown. Here at UPS, we do have both Center of Excellence and Mechatronics Lab. In this, students can go through various pneumatic systems and hydraulic systems. Students can work can do R&D activities. Students can design. They can realize their ideas into the product and they can launch into the marketplace according to the field of interest. Here in this research center of excellence, students are free to work through various pneumatic systems. Similarly, we do have experiments in heat transfer laboratory based on conduction, convection, and radiation. The figure depicts refrigeration and air conditioning laboratory equipment where refrigeration experiments can be carried out. I would like to say the significant career opportunities for the field of thermal engineering expertise, as various industries or various fields are offering many uh, career options for the mechanical engineers, especially as I was started with the uh, view of thermal engineering expertise. So with the conventional mechanical engineering, as I was mentioning the differences between conventional mechanical engineering and with the expertise of thermal engineering. So students may be offered to many opportunities where thermal engineering expertise is required, like thermal power plants. With conventional based systems, thermal power plants like solar thermal power plants and waste heat recovery systems. So based on this solar thermal power plants, the students will, as the exposure, students having exposure on the solar thermal power plants, so they may get easily placed in these systems. Similarly, automotive industries are open to the mechanical engineers, aerospace industries, ship and railroad companies, and processing industries, design utility companies, steel industries, foundry, civil construction companies, waste heat recovery energy systems, food processing industries, garment industries, pharmaceutical industries, pulp and paper technology industries, academia, and consulting companies. The breadth of mechanical engineering discipline with thermal expertise allows students in variety of career options, not only as mentioned in the above list, and students may get global opportunities also. So not only as mentioned the above listed industries, so many sectors may offer the various career options to the students, those who are having thermal expertise. Thank you. Welcome to UPES Dehradun. If you have any queries, you can ask now. The participants may post any queries. I would request the participants may post your queries for the proposal program. If no query is posted, thank you for listening. Thank you for giving attention for this webinar. Thank you.